Well, good ICSI day, everyone. We're starting this session with a MIP award, and the awardees this year, as we have announced earlier, are Abram Hindle, Earl Barr, Mark Gable, Zendon Su, Prem Devambu for the paper on the naturalness of software, which was published in ICSI 2012. And the program chairs back then were Gil Murphy and Maura Petze, and they led the committee that identified this paper as the most impactful paper, most influential paper from 10 years ago for demonstrating the applicability of statistical language models to build tools to aid software development. So today, Abram, Earl, and Prem are going to tell us more about that paper and reflect on its impact and derivative work that came out of it. And a big shout out to the authors and a big encouragement to everyone out there to take a look at the paper. It's a different kind of paper. It starts with a very clean hypothesis connecting software development or programs and NLP models, and in that sense, a piece of pioneer work. I'm really looking forward to the presentation, and again, congratulations to the authors.
All right, thank you,
Go ahead, whenever you're ready, Abram.
Hi, I'm Abram Hindle from the University of Alberta.
Hi, I'm Prem Devambu from UC Davis.
Hi, I'm Earl T. Barr of University College London.
Okay, I'm going to start with a couple of examples that'll hopefully pique your interest. First, let me ask you, do these two code fragments above mean the same to you? Most of you would probably say yes, it's just a factorial function. There's nothing in these fragments of code that convey any other intention. Okay, let me show you one more. How about these two? Do they mean the same thing? On the one hand, from a purely computational perspective, they're exactly the same. But I suspect many of you would still say, no, they're not the same. For those of you who are in doubt, let me ask you this. Let me give you a perceptual association test kind of thing and ask you, which picture on the right would you associate with which function on the left? Find the richest? Find the heaviest? I don't think any of you would really hesitate, right? Right? So what's my point here? The point here is that code has two audiences. One audience is the machines on which the code must run correctly, and the other audience is the humans who must understand it to maintain it and extend it. Therefore, for this reason, because of these two audiences, human programmers strive to write code that is not only correct, but also works for humans. Right. Okay, so let's put a pin on this two-channel thing that I got going on in the previous slide, and we can come back to it later. Turning back to naturalness, let me spend a few minutes talking about the idea for this paper that we wrote 10 years ago, for which we're now receiving this MIP award. Thanks again to the selection committee for picking this paper. So the idea we talked about 10 years ago was that the way we humans use language to talk and to write has evolved naturally to meet human needs, to communicate, for food, to find food, to care for our young, to find mates, and so on. So our argument, again, 10 years ago, was that the way we humans code has also evolved to meet human needs, rather than just run on computers. So what is this naturalness, and where does this arise? So first, for natural language. Human beings communicate using natural language. However, our attempts to communicate are stymied by distractions. To overcome these obstacles, we often express ourselves in ways that'll work even if our intended audience is distracted. So natural languages, as they're used, are redundant. They're repetitive, predictable, and highly amenable to statistical modeling. This is great because this enables things like speech recognition, translation, and so on that make our lives much easier. Code, on the other hand, has formal semantics, which are faithfully followed by computers. So if a tiger were to wander the hallways of a server farm, it's going to just ignore it and do what we tell it to do faithfully. On the other hand, human beings don't interpret the code formally. They are subject to all sorts of distractions. And so thus, code has two channels that are not exactly the same. One of them is formal and not subject to noise. The other one is. So from this comes about the naturalness of code. Even though code has formal semantics, it is subject to noise when humans read it. So like natural language, the way we humans write code is repetitive, predictable, and amenable to statistical modeling. In a recent paper, for example, we found that even though these two ways of incrementing I equals 1 plus 1, 1 plus I, and I equals I plus 1, are exactly the same, the one on the left is much more preferred, and in fact, is easier to understand. So that's the naturalness of code. So why does this matter? Tools. So let's think about the way people normally bring tools. Some developer has a great idea for a tool, so they build it, and then they can run the tool on source code and produce output. So maybe it's going to check for defects, maybe it's going to check coding standards, maybe it's going to produce a UML diagram. Once the developer builds the code, they can test it and use it. Often, however, such tools make various approximations and design trade-offs because of scale, computational complexity, and such. These approximations and trade-offs mean that in practice, the performance of these tools is often sub-ideal, sometimes too conservative, sometimes too adventurous. So is there a systematic, principled way to build a tool so it's most likely to work on most code? That's where naturalness comes in. So we start with a large corpus of code, which essentially has latent within it a lot of knowledge about how to make tools work better on real code. So because of naturalness, we can estimate statistical models over these large corpora. And this model, probabilistic model, can help our tools work better. Because we have very, very large corpora, we can make the model very good indeed. So how does this probabilistic model help the tool? Well, essentially, these models, when built into implemented tools, can help us do things like classification, ranking, prioritizing search, etc., much better. So a little more specifics on what kinds of things are possible, right, in our papers reported over the years, right? So there's various kinds of probabilistic models one can estimate. I won't talk about all of these, but you can use it to check code. You can use it to recover names. You can use it for gradual typing. You can use it for code suggestion, which is what is built into Copilot. You can do code summaries. You can do retrieval of code. You can assign people to tasks. Lots of opportunities for applications. There are almost 1,000 papers in the area, if not more. There are several startups. All the major software companies have groups that work on this. So it's a very active and exciting area, and I invite you to join us.
Hi, I'm here as Abram Hindle to talk about the work that I did at UC Davis with Prem Devambu, Zhendong Su, Mark Gable, and Earl Barr, especially with other lab colleagues such as Foyger Rahman and Daryl Posnett. So I joined UC Davis at the start of this project. Prem basically said, oh, let's do something along the lines of NLP applied to source code. I think he was interested in my latent Dirichlet allocation topic analysis work that I'd been doing at the time, as well as other artifact analysis. So we started off by basically going to Crepeville, a crepe restaurant near campus, at least once a week, and having meetings or reading group sessions about the Manning book, Foundations of Statistical NLP. In that, I don't know if we really got much further past chapter 3. We kind of really latched on to Ngram models. We weren't too interested in the other tree stuff and the tagging, but the Ngram models seemed really neat. So we were trying out the Ngram models, and the results weren't making a lot of sense because it turned out that there was a lot of unseen vocabulary and a lot of unknowns. So in a basic Ngram model without smoothing, you're going to basically bottom out on your probability. You're going to end up dividing by 0 because you haven't seen something. So what we had to do is we had to investigate smoothing. So we started off with like just the good Turing smoothing, just like a +1, or just pretending we saw it once. And we were finding that wasn't really working that great. So we looked into other Ngram models, and we found MITLM, which was a G4trans/C++ based implementation that was really fast, used this hashing mechanism, these hash chains that worked really great. And it worked for what we needed to do, and I could modify it enough such that I could make it updatable. So I could send it new information, and it could update the counts and the chains such that it could do estimation. Even better, it came with a really nice smoothing algorithm, modified Nezar-Ney. Once we got that working, I jammed that all into Emacs because we basically daemonized MITLM, and it had a Perl script that could basically query it. So once it was up, you could basically query from Emacs based on your current file what you could code complete, and everything that you had sent to it to code complete, it could learn off of. We knew this wasn't really going to fly for something like ICSI, so we had to move from fun languages like Perl to more boring languages like Java. So we employed Eclipse, its code completion framework, and we set the Ngram model on Java for the most part. But we could do just about any other language. So in the paper, there's evaluations on C and other kinds of things. But we wanted to compare, at least for code completion, against a mature code completer. So we used the code completer in Eclipse at the time, which was very popular. So what I had to do for the final evaluation that compared against Eclipse is I had to force Eclipse to code complete way over 30,000 times. So I had 10 VMs on Amazon AWS. They were running concurrently, and I had VNCs open, making sure that Eclipse wasn't dying on me, because it always would. Eclipse was never meant to code complete 30,000 times a second. Eventually, we got down to it, and by the time that ICSME rolled around, we were finishing up our changes to the paper, and we had an excellent result. Essentially, Ngram models modeled source code really well. They dealt with source code in an intuitive way using surprise and perplexity and cross entropy. I would take this work and I would kind of push it into the IR realm and contextual realms. So it was a kind of a different direction. But my students, Hazel Campbell and Eddie Antonio Santos, extended the work quite greatly. They noticed that the surprise mechanism of the Ngram model was quite useful, and you could use that for identifying where syntax errors were, better than a parser could, because a parser had formal rules that would oftentimes kind of blame things just where it broke, not necessarily where the issue was. So what occurred was essentially Hazel wrote an error detector and an error locator for syntax errors, and it didn't need parsable source code. Eddie Antonio Santos extended that and used that to basically code repair the syntax errors. So you have unparsable source code, you could use the Ngram model or an LSTM model to code repair. So they both work very hard at that. I am now currently applying these same naturalness ideas to languages that don't seem to be very language-like, graph-based languages, visual languages, languages used in engineering, used in music, and used to teaching programming. These visual languages are often data flow driven, yet the current analysis we've done on their code clones and their repetitiveness shows that indeed these visual languages are quite natural. So that's where the next bit of my focus is going to be, in the area of naturalness. And I thank everyone involved. It was a really great experience.
Since working on the naturalness paper, I have had the good fortune to enjoy nature hikes with many collaborators and enthusiastic naturalists. I thank each of them. Prem and Abram have talked about where we've been. I'm going to tell you about one direction we're headed. Code has two audiences: the machine that executes it and the developer who must understand it. To satisfy both audiences, programmers try to write code that is both correct and easy to maintain. These twin audiences and two goals give rise to two channels. The algorithmic channel carries all the statements that the code needs in order to run correctly. The natural language channel carries the cues like names and formatting decisions that help programmers understand the code. These two channels share tokens and are intertwined. Example dual or cross-channel interactions include names, like function names, layout, and ordering decisions. And why? Because developers use both channels. Some of these interactions form constraints. For example, renaming a function that actually computes the Sivarastanies like this one does to Josephus would be confusing and slow down understanding the method. To explain how dual channel constraints arise, we turn to Shannon's noisy channel model as adopted in psycholinguistics. To resist noise, the speaker chooses an encoding for the intended message that maximizes the probability that the listener receives the intended message. In the context of code, the intended message is the specification. And again, we have two audiences. In the development setting, the programmer chooses an encoding, specifically code, to maximize the probability that n equals m prime, that both audiences get the intended message, given the code. Because the code is dual channel, programmers prefer encodings where the channels synergize rather than antagonize. Dual channel constraints arise from this preference. The two channels are asymmetric. The machine mostly ignores the natural channel. For instance, the machine ignores identifier names up to alpha renaming. If we end this asymmetry, the machine can help the developer understand the code better and faster. Dual channel analysis aims to do just that. This theory was published in NEAR 2020. It has three consequences. It offers a new angle on age-old questions in linguistics. Consider the question, why do people choose to say things the way they do? In English, bread and butter is preferred to butter and bread. If someone says butter and bread, are they joking or is it a mistake? It's hard to know because in natural language, reordering almost always changes the meaning and mistakes can be intended and meaningful. In code, expressions like I plus 1 and 1 plus I are semantically equivalent. Code allows us to separate meaning and order. Casey, Prem, and Emily conducted an elegant experiment to do just that. They correlated surprisal with mental computation. And they found that developers prefer less surprising code and comprehend it faster. When the two channels are in sync, using both provides more training data. For the usual array of software engineering tasks, the two channels can fall out of sync. Code can do something other than what it says it does, like save your file and send your banking details to evil.com. A function that computes the sieve of Erasthenes can be misnamed, as we saw earlier. Comments can also lose any connection at all to the code they originally commented. Dual channel analysis can detect and report such inconsistencies. Thank you.
All right, I'll call my co-authors to the stage.
And we invite the audience to put questions on the chat if you have them, and we'll read them out loud. And I want to ask you the first questions, and while you were presenting the move forward and the work, the whole story of the work, I was wondering if you could tell us a little more about the waves that he has made. I think you alluded to these, but the waves that he has generated in the community that go beyond your own groups or your own students. Can you tell us a little bit about some efforts that you have seen, or how you go about assessing the impact of your own work when you look outside of your own groups?
There was one paper that I really liked that was really in line with the original naturalness paper, and they went out and they tested all different kinds of smoothing algorithms, which was a little dry, but I think was completely necessary because there wasn't necessarily a lot of real empirical work like that. So I thought that was really neat. And then afterwards, there was a big focus on deep learning, and then I'll let Prem answer that one.
I was going to say the biggest tsunami is Copilot. It's phenomenal. I still can't believe it. It just blows my mind. So I think these 150, 200 billion parameter models, I still can't get my head around what they're doing and what they can't do. So I think that's the biggest wave.
I'm just gratified to be part of it. I just see so many papers published that I can't even keep up with them all, and I'm gratified that that I was fortunate enough to be a pioneer in this space.
Absolutely. And beyond code completion, where do you see the next round of, or the next set of or the area that is going to be impacted next? Because I think the original paper and a few of the follow-ups alluded to a few areas, and I think code completion was kind of the first one to that you latch on, and the first one actually that has been probably exploited to this extent in the community. But where are the others where you see, I guess, the upcoming wave, Prem? That's what I'm thinking about. What are the next few ones that are coming, or that you perceive coming?
So I guess, these days, it's all about these large language models, and they do, because of this regime of like pre-training and then fine-tuning, the models learn to represent text, and they appear to learn the meaning of text in various ways. And so there's a whole lot of application. You can look at Codex Glue. There's a benchmark put up by Microsoft China that has a lot of different tasks: code summarization, code retrieval, code synthesis, code translation. So there's a whole range of applications that are coming out. So it's an exciting time because like in NLP and AI in general, these large language models are promising to really change, BERT, CodeBERT, Graph CodeBERT, and now Copilot. So Codex is what GitHub calls the model. So it's really exciting.
Absolutely. I think Matt has his question up, and there are a few coming on the chat. But Matt, why don't you take the power that you have for a few more hours to exercise that and ask a question?
I use the physical hand, not the virtual one. So I was quite interested to hear Abram comment on the naturalness of what I'll just term unnatural software, or software that doesn't seem like language. And let me push it further and ask a question about whether there is a component of naturalness in this brand new kind of software that we're seeing now, which are trained by machines. So when I think about a trained machine learned model as a function approximation that I want to drop into my software system, pull out the human written heuristic, drop in the machine learned model, what happens to the naturalness story here? It seems like I've destroyed this other channel that you talk about.
So in terms of visual programming languages and maybe no-code languages, they still have to communicate to people. So Earl's dual channel model still matters. So it's still communicating to two things. And I think what makes a lot of the visual programming languages relatively simple is the fact that identifiers get thrown out in a lot of cases, because if they're a data flow language that uses arcs to indicate where stuff goes, they're basically not needing an identifier because they have a visual representation. So that simplifies that. My colleague, Alona Fish, she works on comparing EEG and fMRI results to neural network results. And what she's finding is, in terms of speech and visual cortex and stuff like that, there is a correlation. I'm not saying causation, I'm not saying they're the same, but if you compare RNNs to, or you correlate RNN outputs and RNN representations with some of the language outputs, like embeddings of EEGs, you get a correlation, which is kind of weird, kind of indicating that maybe some of the neural net stuff could actually be natural, which feels a little bit weird. Earl's got some comments.
Definitely not the tensor of parameters, but like you're saying, there's some other representation of what's going on that does have this kind of alignment. That's very interesting.
I think you have a couple of questions on the chat. I'll just read them out loud for the audience. But the first one came from Bashar, and he's talking about whether you have observed, first of all, congratulations on the paper. Outstanding work, creative and deep. And Bashar is asking, have you observed what provides more leverage in software engineering? Is it naturalness or unnaturalness?
Good question. I'd say that naturalness does exploiting exploiting the patterns that exist, and as opposed to looking for violations of them, because it's helping tasks like translation, which has been employed for porting, obviously the completion, which has culminated in Codex Copilot. Prem, you look like you have something to add.
I'm not sure. It's a really intriguing question. Hopefully, we can have a chat offline about this. But so I mean, natural language, stuff written by Shakespeare or or some other great author is unnatural, right? I mean, it's weird because that's what makes it special, right? So maybe the algorithms written by Keynote, I find them hard to understand. Maybe they're natural. Maybe it's really important. So on the other hand, if you keep writing code that is genius level and nobody can read it, then nobody can maintain it. So what's the point? So it's a really interesting question. Maybe we can catch up with it offline. Mm-hmm. Most code is natural. I mean, that's by definition. And we also know from human experiments that if you write unnatural code, it's hard to understand. So I guess the rule is unless you're a genius, don't write unnatural code.
Yeah. So I think there is. So the question goes about the unnaturalness of code having value in recognizing something that is unnatural, maybe as being
definitely
problematic for maintenance or.
Well, I mean, there's been successful work on both sides, and Abram has the finding errors. So it's been looking for unnaturalness has found many errors.
Mm-hmm. Yeah, 1 minus naturalness or the inverse of naturalness can be very useful. Shows stuff that you're not really expecting. Can be bugs, can be errors. Like Prem's postdoc or student was working on that as well.
Yeah, mm-hmm.
and even if not bugs or errors, that should be removed. Code smells, if you will.
Excellent. So there's one more questions here that I want to read out. But first, just a quick follow-up on that. Do you see things like you see natural language in programming, where you can see first-time learners of a language, or people that are, do you see any analogies between those use of natural language where we recognize people that are learning a language or they're moving to a new country and just first-time learners of the language? Do you see the same issues coming up in in programming languages?
No, it's a fascinating question, but go ahead, Abraham. I'm sorry.
Okay, so I've looked at the BlueJ data set, which has a bunch of new programmers learning how to program for syntax errors and has some professionals in there as well. And if you look at least debugging strategies, the professionals know how to debug and the newbies don't. The newbies engage in random edits hoping the program will work. Eventually, when the professionals fail, after a while, they turn into random editing. So it's interesting. It's more like training how to explore how to use the language itself. In terms of learning, I'll push that off to Earl or Prem.
So I think language learning and how language learning relates to programming learning is a really deep question. And I'm hoping to look at that next, actually. So I think it's a really interesting question. Yeah.
Excellent. I think we have time maybe for one more or two more questions, if you guys answer them quickly. I think there's a question here about what do you think people have got wrong and are misusing for, and they're referring for naturalized and language models in SE. Where do you think people got it wrong and are misusing or abusing such notions of naturalness or language models?
I have an example where people should be using it, where it isn't being used very often, and that's in reinforcement learning for heuristics, for searching for successful policies when you're dealing with language tasks. There's not a ton of reinforcement learning in software engineering anyways. So hint, hint, hint to anyone out there, reinforcement learning and naturalness.
Okay. Maybe just anything to add, Prem or Earl?
I don't know that there's any wrong approach, but there are certainly some controversies, some questions in my mind about, which is the right way to go. So, for example, we have a lot of arguments about whether modeling of naturalness should be done at the lexical level or at the syntax level or at the semantic level, and doesn't make any difference. There's a lot of people pushing on graph models, for example. So, I think the jury is out, mainly because these very highly parameterized language models have such tremendous power. Maybe they're actually learning the statistics at the syntax and semantic levels. It appears to be so, in my opinion, but, we'll find out.
Okay. Yeah. Well, guys, this has been fascinating. I'm sorry we don't have more time. And I know that I just want to put a plug for, I believe Prem is going to be coming to ICSI physically. I don't know about the others. So when he's there in person, we'll have more time to interact and ask him about this work. Earl and Abraham and the rest of the authors, I hope you stick around. There are sessions after this where people can hang out. I know there are a few more questions there that we didn't get to. Congratulations and thanks a lot, guys.
Thank you.
Thank you.
So, hello everyone. I hope you can hear me well. We are moving over to our next super distinguished keynote speaker, which is one of my personal heroes in the software engineering community. Heroes, actually, well, superheroes, actually. And one of my role models and one whom I consider one of the most influential figures in software engineering, and whom I always wish to have even more influence in software engineering. We're moving over to the 2022 winner of the ACM SIGSOFT Outstanding Research Award, Lionel Briand. And Lionel, I think he's Europe's most cited software engineering researcher, outstanding and exemplary work joining academia and industry. He's going to tell us a bit about the many views one can have on software engineering and software engineering research. Lionel, super happy and super honored to have you with us today. I hope you're still here. Right now I'm all alone. And if you can, try to share your slides and we'll be with you in a moment. Lionel was here just seconds ago, so I hope he'll be able to come back. A few ideas on Lionel's achievements. He's an IEEE Fellow, IEEE Computer Society, Alan Mills Award, Reliability Engineer of the Year, ERC Advanced Grant, ACM Fellow, Most Influential Paper Awards, multiple, and now the ACM SIGSOFT Distinguished Research Award.
Can you hear me?
Lionel, I can hear you very well, and I'm sure the rest of the audience can do so too. So now's a good time to find out how to share your slides, and there should be a little button with Start Sharing Screen in the lower left corner. If you press that one, we will be able to see your display. We can hear you, yes.
Okay, sorry for that. It's a usual problem. All right, let me share. Can you see my slides?
We can see your slides, Lionel. That's all. Perfect.
Very good. Good morning, and sorry for that.
And go ahead.
I thank you for the very kind words. I don't think I'll ever get used to giving a talk on the screen. Something always happens. I look forward to meeting all of you in person in Pittsburgh. Let me start maybe by thanking my nominator for this award, who had to go through the process twice. And many thanks also to the selection committee and conference organizers for arranging this talk. I'm very honored. Though I realize this is customary, I won't talk much about me or my career or my achievements today. Rather, I'd like to talk about us, all of us, as a community. Some of you may have read the abstract of this talk. It was, of course, an attempt at humor to attract attention, hopefully a good marketing strategy. But I'm afraid this presentation won't be nearly as funny. And if you hope for provocation, you will also probably be disappointed. My goal here is to just provide food for thought, pose questions, and simply trigger discussions. When you receive such an award, hard work and serendipity play a big part, of course. However, the people you meet along the way, their influence, support, also play a crucial role. Therefore, I can start this talk without briefly acknowledging a few people. First and foremost, my PhD advisor, Vic Basili, without whom I would not be here today. I'm also very grateful to the many students and collaborators I've had over the years, whom I cannot, of course, enumerate here. And last but not least, my family for their patience and tolerance with my unfortunate academic obsessions. I started very early in my career asking myself questions about the purpose of what I was doing. Publishing or even getting awards was simply not fulfilling. And actually for a long time, until a few years ago, I was not even a member of the ACM and could not be nominated for any awards. Until I realized a little bit late that it was expected from me in some way. So on several occasions, I asked myself even if I wanted to continue in academia or even software engineering research. I couldn't just accept spending the rest of my career addressing problems I'd simply identified by reading other academic papers. At the very least, I wanted to take a shot at having some dent, no matter how small, in the real world. And on this slide, actually, is a quote from a very wise man, Adam Grant, a person I like to read. It is probably my most important advice to younger researchers. And in short, happiness is a function of how you spend your time. Success is a temporary thrill. And I think that's a key message. What I guess in the end really kept me doing this job are the students and postdocs I had the privilege to advise and learn from. Here is a picture of my group in Ottawa, young, friendly people with whom I spend time in the lab and occasionally play table tennis, football, or pool. And thank you again. But now, as promised, let me share with you the results of my reflections on our community over the years. Traditional engineering disciplines, for example, mechanical engineering, aerospace engineering, are rooted into physical sciences with some contributions from applied mathematics such as optimization, control theory, and so on. Software system engineering is very different in nature than such traditional engineering disciplines, both in terms of artifacts and practice. The education of software engineers is not fully standardized. Many people of various backgrounds develop software, in part due to the chronic shortage of qualified people. The process of development is also not nearly as standardized as other engineering practices. Our standards are typically very high level in the few domains where they are applied, such as safety critical domains. Development is still a very human intensive activity, as we have not managed yet in practice to provide effective automation for many tasks. Software systems are designed to be adaptable to variations with respect to customer needs and environments to a rather extreme degree. Not being physical, software undergoes massive and frequent change, typically over many years. And software systems have no continuity properties. Small differences in operating condition can result in dramatically different behavior. As a result of these observations over the years, the field has evolved into three largely distinct sub-communities. This is, of course, an oversimplification. 30 years ago, the focus was very much on formal methods. For example, the work of Harlan Mills, after which the IEEE award was named. The main objective of formal method is to provide guarantees regarding the dependability of components or systems. And then increasingly, people started to recognize the importance of human and organizational factors in software development. At the same time, or perhaps as a result of it, a greater part of software engineering research became empirical in nature. And last but not least, as software systems grew in complexity, smart automation of various tasks became a priority. For example, in the area of automated testing using evolutionary computing. And one crucial objective has been scalability. All things considered, this picture is a rather natural evolution given the nature of software engineering as previously described. However, we expect these three areas of activities or sub-communities to interact. Formal method and smart heuristics, for example, based on machine learning or evolutionary computing, can be combined to achieve scalability and appropriate trade-offs to enable practical use, for example, under the form of probabilistic guarantees or other aspects. Both formal methods and automated solutions usually rely on assumptions and carry practical limitations. They are normally initially evaluated in vitro, to reuse a medical term, based on limited, often artificial artifacts and use cases, and usually by the researchers themselves. But eventually, because of the human factors mentioned earlier and limited resources in practice, some form of in vivo evaluation is desirable. And this is where human studies could come into play to better understand the interplay between human factors and technology. In reality, however, if you look at the research published, these three subdomains or communities are largely disconnected. In other words, research on the interaction of these communities is very limited. Formal methods focus on things like solvers, theorem provers, symbolic execution. For example, for symbolic execution, how to cope with floating points, or for SMT solvers, devising more extensive background theories. The engineering side develops sophisticated heuristics to automate tasks like requirements quality, refactoring, or various aspects of testing, often based on a combination of technologies, including evolutionary computing, machine learning, natural language processing. And the use of research encompasses a diversity of topics, ranging from analyzing tweets among developers, question and answers on Stack Overflow, all the way down to studying the effect of cannabis. Though formal methods were the original emphasis of the field, it represents now a quite small minority of papers published at software engineering venues. For example, this is a frequency of papers among those nominated for distinguished paper was based on my reading of their introductions. I didn't want to read 200 introductions, so I quickly looked at a random subsamples of all papers, and these proportions are roughly correct. As a side note, 5 of the engineering and human and social papers rely on open source systems and data for their studies. So if you look at the papers across these 3 categories, here, for example, are abstracts from some random nominated papers. You will notice that they are entirely different in terms of the background they rely on, the language they use, and the research methods they employed. And that diversity in research is actually what we need as a field, based on my earlier description of software engineering. But those communities need to be significantly connected somehow. We need to be able to talk to each other and work together. And only then we have a chance of providing effective novel solutions that will somehow maximize our impact, in my opinion. And I have a slightly provocative related question. Would it change anything for any of those three sub-communities if we attended different conferences and published in different journals? Think about it, I'm not sure. Let me also raise other questions for each one of those three sub-communities. Though I don't have definitive answers, these questions are worth asking, in my opinion. Have you heard of the football test for human and social studies in software engineering before? I was told this was raised for the first time by Michael Jackson, but I didn't ask him to confirm, so I need to investigate. Assuming that you replace the word software engineering by football in a paper, for example, if the paper abstract still makes sense, is it still software engineering research? In other words, are the questions posed affected in any way by the software engineering context in which the studies take place? Interesting question. Regarding the engineering side of things, for practical reasons, we often rely on open source systems for determining issues and evaluating solutions. Does that bias in our research, and to which extent does that bias our research, and what are the consequences for the community? Indeed, open source systems tend to be often utility software and much smaller than the industrial systems I've worked with. Also, they are not representative of many important types of systems, such as cyber-physical systems. And as I've argued before, in a paper, context is everything in software engineering. So it somehow drives the applicability and benefits of any tentative solution. Regarding formal methods, how do we distinguish software engineering research from applied mathematics or computer-aided verification? What if the research is a purely intellectual exercise with limited connection to software engineering reality? Of course, I have heard the argument before that for at least 2 decades, that eventually such intellectual exercises contribute to actual solutions. But I have seen limited evidence of it. Now, I briefly talked about impact. What does that mean? And how can we maximize it? Of course, the impact comes in many different forms. The timeline of research may differ. The mechanisms through which impact happens are multiple. The evidence of impact comes in different forms. And actually, most practices nowadays are not supported by any empirical evidence. In my collaboration with industry, I usually go through the following steps. I try to determine the scope of collaboration. I define the problems and prioritize them in collaboration with my partners. I read the research literature, I identify the gaps, I plan the research, and so on. And in the process of going through these steps, the dialogue with industry partners usually works like this, at an abstract level. Usually they ask me, okay, so what are the solutions available in the research literature? And usually, I'm a bit slightly embarrassed and I tell them, well, there are interesting ideas, but nothing that fits your needs, nothing that can scale to your systems. We have a great deal to do, it's going to take X years and it's going to cost you a lot of money. So, often there is a lack of operational, scalable, and practical solutions, even in well-researched domains or problems. For example, recently, a year or two ago, I worked on regression testing, a topic that is, relatively speaking, extensively investigated. And it was in a continuous integration context with frequent builds and large systems. And basically, I couldn't find an accurate, applicable, and scalable solution that I could apply with minimal work. So, related to research impact, or lack thereof, Ben Schneiderman, a very well-known HCI researcher, proposed in great detail a different research model. of course, focused on applied fields in a book entitled The New ABCs of Research, Achieving Breakthrough Collaborations. And if you have not looked at it, I strongly recommend it. At a high level, his thesis is that a linear model of research for applied field is ineffective. By linear, he refers to the model where you do basic research and the results somehow percolate to applied research and the results somehow percolate to innovation. And rather, he proposes a collaborative model of research and innovation where basic research and applied research take place in an actual innovation and development context in collaboration with smart and motivated professionals. And the expectation is that such model provides dual benefits in the form of publishable research results, but also a focused practical solution that serve an existing or foreseeable market. And in software engineering, we can, and there are many other details, of course, regarding that model. Basically, the idea is that applied research feeds basic research. It lowers the barriers of technology transfer. And though that model is actually quite common in big companies like probably Google and other GAFAM, many companies cannot afford to have such a top-notch software research department or quasi-universities, especially those whose core business is not software engineering, such as automotive or aerospace companies. And this is where public-private partnerships can then play an important role in such cases. And if we want to implement that model in software engineering, there are different ways to do it, but one way I've been using to do it follows the model that has been proposed earlier by Gorshek et al., a model where research is driven by industry needs. We perform realistic validations, and we try to combine research with technology transfer and innovation by following a number of steps where we identify the problems with partners, we reformulate the problems in scientific terms, we perform state-of-the-art review, identify gaps, devise candidate solutions, I'm going very fast here, perform some initial validation in artificial context at a low cost, and if obtaining promising results, move on to more realistic evaluations in project contexts, requiring some degree of training, and then eventually release a solution and iterate on those steps. But to promote such a research model, we only have a role to play. Institutions need to support such partnerships through technology transfer offices by enabling industrial leads or faculty members and other things. Funding agencies need to support through specific programs such activities. Private companies need to agree with long-term commitments and open science. And academics need to develop an appreciation for demand-driven research in industrial contexts. And though I'm not going to go into details, this also has an impact on our publication model. Some of that has already been partially implemented to various degrees in some countries. And to me, this is the way ahead to maximize the impact and prominence of our field. However, having said that, just to clarify, the goal is not to forbid curiosity-driven research, but to encourage demand-driven collaborative research. For Star Wars fans, we just want to bring balance to the Force. And based on these last philosophical words, I thank you for your attention. Thank you.
Thank you very much, Lionel. And I think, please everybody use the best of your applause buttons and applause mechanisms. Turn on your cameras, and everybody, please, right here, as much as you can, virtually, congratulate Lionel for his great talk, and of course, the ACM SIGSOFT Outstanding Research Award. Okay, thank you. Oh, we had one, finally, wonderful. Super happy. I'm super happy to accept questions for Lionel, and you are going to find the chat window on the right side of this space. And I'm super happy to give questions. We have a question from Daniela Damian, co-PC chair of ICSI. And Dania, the microphone is open. Go ahead.
Hi, thank you. So warm congratulations, Lionel. and welcome back to Canada. You have challenged us along all these years about practical impact of our work, and that's what really makes me think that and say that you're my role model. But the question I have to you is, if you were to change the way we evaluate researchers and research work, right now we still use publications mostly. But working with industry and solving or addressing industry needs requires fewer publications, requires longer time to publication. Sometimes it's even difficult to publish. So there's a clear dilemma in using the publication system as a mechanism or metric for assessing impact or talking about impact. What is your proposed solution to that?
Yes, that's a question I was expecting. By the way, I hear another conversation, so if you could mute your mic, I'm not sure where it comes from. Well, of course, I mean, that's the $1 million question. Well, it's very unfortunate, of course, that we use evaluation criteria for research. Of course, I know this is not the case everywhere. Usually, top universities don't use such criteria, actually. I remember once MIT asked me to write a letter for a tenure case, and they couldn't care less about the publications of the candidate. They just asked me what was his contributions and why was that important. That's all they care about. So I found that interesting. But of course, we have to change the evaluation criteria. I mean, this is basically undermining us as a research community. It's undermining our capacity to have impact. And but of course, I'm sure many people here agree with that. I'm not saying anything particularly insightful. But it's true that doing that kind of work is extremely time-consuming. You can spend months trying to understand and define problems before you have even started to doing your research. Why? Because problems in software engineering are not universal. At least they are universal at a very high level of abstraction, but they are not universal at a concrete level. Context is extremely important. Context will determine which solutions are going to be beneficial or even applicable. It will drive your research to a large extent. So that's something that everybody has to accept at all levels, funding agencies, institutions, peers. Also, usually when you try to solve real problems in real context, you do not come up the first time around with a perfect solution. There are usually limitations, there are things you haven't done, But I know that type of papers usually, even when everything goes well, take 2 years to come out, at least, full time for a student or postdoc. So I don't know what else to say. If you have a more precise, another question related to that, just ask me. I'm not too sure what else to say.
We have a Birds of Feathers session at the in-person event on the topic of impact in software engineering. So maybe we can continue with that.
There are other questions, apparently.
Okay. Let me get you a question from the chat window. And start with Dror Fettelson. Your emphasis is on impact in industry, which is obviously important. But is there a basic science of software engineering? And if so, what is it?
Well, that question can be interpreted in two ways. Every engineering discipline, even mechanical engineering, aerospace engineering, is based on some, mother sciences, I'm not sure how to call them. So in our case, it's computer science, but not only, especially because of the human side of research. But there is another way to interpret that question is, where do we do science when we do software engineering research? Every engineering discipline follows the scientific method. in devising, in understanding problems, in devising new solutions. We follow the scientific method. So we do science. You know, once we have identified the problems, we elaborate hypotheses, you know, etc. You know, so we are scientists because simply we apply the scientific method in everything we do. But not only, because engineering research is also about innovation, new ideas, devising new ways of doing things. So it's not just a matter of expressing hypotheses and verifying hypotheses. It's about the eureka moment, the new way of doing something, of solving the problem. And there is no recipe for this. I mean, it happens or it doesn't. And if it doesn't, you are in a limbo for years, unfortunately. So I think I stop here.
We are getting dangerously close to the closing session. So, and Matt is the session chair of this one. Matt, can we have Lionel answer one more question? Is that okay?
Sure.
Matt says yes. Okay, and I'm going to pick one from Jane Cleland Wang. Lionel, where do you see the balance between academics solving practical problems as defined by practitioners and proposing innovative future ideas that are more visionary and go beyond currently defined pain points?
Yes. Actually, as I've said actually at some point in the presentation, we don't need to work only on current problems. We can sometimes we work on future foreseeable problems, things that we see coming, problems that are arising and will grow in prominence in the future. But of course, it's very hard to do relevant research if you don't have a clear idea of the problems. However, of course, we are researchers. Sometimes it takes many years to actually make a dent and find an appropriate solution. So funding mechanisms and our industry partners have to be accepting that way. They cannot expect us to only play a role in the short term in solving their short-term problems. So usually you have to find a balance in your relationship with your industry partners where you partly contribute to their short-term problems and you partly work on their long-term problems. And that's also why you need funding mechanisms that are hybrid and that allow you to work in the long term on industrial problems. Yes, anyway, and again, the last point I've made, my point is not to forbid curiosity-driven research. My point is to reestablish some form of balance. You know.
Okay, we take this as your closing words and a message.
Thank you very much.
To take over. Thank you again, Lionel, and congratulations one more time. Here we go.
Thank you.
Keep up the good work.
Kind words.
You, Lionel. And
cheers.
With that, I am happy to hand over to Matt Dwyer and I guess Laurie Williams for the closing session. Thank you.
Yeah, I think we'll start with closing comments from ICSE 2022 and then hand it over to Laurie. So I'm going to share my screen. Hopefully you can see my slides. So we're coming to the end of the main ICSE, the virtual component of ICSE, and want to just remind you that it's a very long festival, and so we're just done with the first week of the 3-week festival. You might be curious, like how many people are engaged in the platform, and the MidSpace folks were nice enough to add a feature that allowed us to track this at a kind of a aggregate level, and we've been doing so over the past few days. And we're seeing pretty consistently 200 to 300 people on the platform, around 370, I think. And so that's a pretty good turnout, and this is happening in all the time bands. So that's a pretty good number, I think. Want to just take a minute, give Dana Damien a chance to talk about one of the things that's going on behind the scenes that you're not aware of, but I think it's in many ways responsible for kind of the smooth operation of ICSE 2022. So Dana, you want to explain?
Thank you, Matt. Yeah, if you could actually put the slide before for a second. So I hope you enjoyed the sessions. As you can see, if you remember, we had 4 days. We're in the 4th day of the ICSE blended sessions, which when Andreas and I had this, what we thought was an innovative idea to have every paper presented in 2 sessions. We had no idea how complex this might be. We had all this figured out. We would send a survey to authors and survey them on the preferred time bands, allowing them to choose 2 out of the 3 time bands to present. So we got survey results back. We had this sophisticated mechanism to create the program automatically, and then we tweaked it. So thank you very much to our to Andrea's student who helped us with that. But then it was actually the implementation on the day and getting ready to have all these sessions work out. So if you can show the next slide, Matt, it felt like creating an advent calendar. Okay, so we had over the 4 days and almost 24 hours, so 3 time bands with 3 sessions in each time band, we had 152 sessions. And, by now you would get used to, having mid-space where you allocate the authors, you have a session chair and a student volunteer in the system. And then you have the program online. So the list of papers being presented are also online. Well, changes had to happen. Sometimes, we got the algorithm wrong, there's the outcome. Sometimes the authors may not have responded to our survey. So we did take a bit of a risk in assigning some papers to some sessions. And in a couple of times, they were not right. Well, actually, more than a couple, because we had to make changes along the way. And then you actually had to have a machinery behind all this so that the 6 authors in each session were able to present in a nice interactive mode. We needed a student volunteer and a session chair for each of these sessions. So only assigning these volunteers to these sessions, we had for the session chairs that 106 distinct session chairs, an 800-row spreadsheet for this assignment. For student volunteers, 200-row spreadsheet to assign all the student volunteers. And we did all this, and yet during the week we had to adjust all the time. So I'd like to shout out to our student volunteers group, their chairs. We worked so nicely with Claudia, with Michael Hilton, with Alvin and Laura Morena. They were online all the time to move students from one session to the other. The session chairs were phenomenal. We had this, as I said, tremendous Google Sheet. Thank you, Google. I don't know how we could have done this without a Google Sheet, where they were able to contact the authors ahead of time, tell them to connect to mid-space 20 minutes in advance, and try out the system. And we still worried that the sessions would not have a student volunteer or a session chair on the day. So thinking about the Christmas calendar, the Advent calendar, it felt like we prepared for each of these sessions. We prepared everything that had to go inside, getting ready. And on the day, on the hour, we hoped that when we opened the door, everything fell into place and everybody was in there for a good interactive atmosphere for the presenters. And I have to say that for all the sessions that I attended, it worked very well. The authors seemed to have a good time, and the session chairs enjoyed themselves. So thank you so much to all the session chairs for being there and putting up with some of the mishaps that we had along the way. We did also have, I wanted to know, we had a backup, we had a system with backup session chairs, and they were our track and area chairs. We had another massive spreadsheet where they would take a time band in the week and be available. They provided their phone number, and the student volunteer was supposed to call them 10 minutes before the session start. And because I'm paranoid, I actually had a backup to backup chairs. So we had the 3 sets of chairs in line for the sessions. And as far as I know, no session had been run without a session chair. So again, thank you so much to all this tremendous collaborative effort to make the sessions hopefully interactive throughout the week. Now back to you, Matt. Thank you.
Thanks, Dana. Yeah, so we're getting close to the end of the first week of ICSI, and we have another time band with 3 sets of sessions in there. But I want to call your attention to next week, which is when we'll have another set of workshops, as well as the co-located events. In total, there's 30 workshops and co-located events, and this is kind of a hallmark of ICSI. And so we know that a lot of you are going to participate in these, and we'll see you next week. So now I want to just say a few words about the 3rd week of the ICSI Festival. That's the in-person event, which will be in Pittsburgh. I think it's in this picture somewhere, just off to the lower left-hand corner. So here's kind of a bird's eye view of what that week will look like. This is on the current homepage of the ICSI 2022 website, and I'll just zoom in and give you a little bit of an overview. So first, as is traditional, preceding the main ICSI event, there'll be several days in which co-located events are happening. Not all the co-located events are going to have in-person components, but Formalize, MSR, Chase, Seams, and Tech Deck will. And they'll vary in size, but for example, and generally speaking, not be as large as the virtual meetings. So I think MSR has over 300 people registered for its virtual event, but over 80 people for the in-person event. So they'll have enough people to have a really engaging, vibrant meeting. So that'll happen on the 3 days preceding the main program. The main program, kind of sketched here, is going to be organized a little differently than a traditional ICSI. We're going to have 3 different types of activities, and again, trying to foster this kind of interactive discussion and engagement. So in the mornings, we'll have that try, like we did on the virtual platform, to engage the authors in discussion and conversation about their work. And then after lunch, we're going to have demo sessions and poster sessions. And we have posters that were submitted to ICSI as posters, but we also offered the opportunity to any paper presenter who was going to present in person to prepare a poster to be presented in the poster session. And so about 80 plus papers will have a poster associated with them. So each of these poster sessions across the days will have 30 posters in them. So yet another opportunity to engage in deeper conversation with authors about their work. And we hope that's beneficial. The late afternoons will be filled with birds of a feather sessions. Birds of a feather sessions are these informal conversations that are really intended to not be one person speaking or one group of people speaking at another, but really engaging for the audience. A couple comments about these. First, most of the birds of a feather sessions are the topics were generated by the community. So we reached out to the community. Thanks a lot to Bonita Sheriff for organizing that. You know, as you can see here, what we have in the afternoons of these days are 8 different hour-long birds of a feather sessions, and the topics are quite wide-ranging. We'll have a couple of topics that kind of resonate with the keynotes. Jevin West will be there. We'll have a Calling Bullshit BOF, or we'll have one related to Phil Koopman's talk. And we'll have one actually related to the award keynotes that you just saw. So that'll be on Friday on research impact in software engineering, and Lionel, Prem, and Andreas will be leading that off. And let me just tell you a little bit about how that's going to work. These are called fishbowl style conversations. So in that particular one, what it means is that those 3 people will start up on stage and they'll get to say their piece. And then after they're done, walk off the stage and the audience fills up. fills in and gets the mic and gets to say their piece. So for all these topics, we hope you look on the website, you look at the abstract for these, you find the ones that you want to engage in, and you stand up and you engage and grab the mic. So hopefully that's an interesting component for this year's in-person ICSE. Let me just say a few more words about in-person ICSE. We take the safety and well-being of the community very seriously. It's a priority for us. We, of course, just like you, really long for these interpersonal interaction at traditional in-person ICSEs. We love the conversation and the dialogue. We think it drives the field forward, but we want everyone to be safe. And this is why a while back we decided we were going to employ a verification of vaccination status. Thank you, Andreas. And we've also decided that we want everyone to wear a high quality, well-fitted mask, so an N95 or a KN95. And if you don't have one, well, you can get one, but one will also be provided for you when you check in. You'll get your badge and you'll get your mask. In addition, as a kind of a measure that's taken to kind of deal with things that arise on the fly, we'll have information about how you should react if you feel like you're getting sick, or if you feel like you've had exposure to someone with COVID on the way to the meeting. And we'll actually have tests available for you, and you can take those tests, and then based on the results, you can either decide, okay, now you can rest assured you're okay, or you can be more cautious and isolate. Furthermore, the venue that we spec'd out for ICSE 2022 was sized for 2,000 people. We'll only have about 500, but we're not going to pack everyone in. Instead, we're going to spread out and use the space. So we'll have a little bit more social distancing available there. Even further, there's some outdoor space that we're going to set up so that hopefully the weather cooperates, and quite a few people can head outside to eat their lunch or drink their coffee. So we're going to do everything we can to try to make it a really engaging meeting, but also a safe meeting. Just if you haven't filled out your, got your vaccination information verified yet, please visit the portal and do that. You'll need to bring that confirmation to the registration desk to check in for ICSE. Okay, so finally, I want to say some thanks. So we've shown the pictures of the steering committee. We have 69 amazing people who've contributed in a real diversity of ways to the program, and I want to kind of distinguish two different types of contribution. I'll refer to the ICSE content team. So the content team is led by our fearless program co-chairs, Danielle and Andreas. They've been great to work with. Their job is simply to assemble the scientific content to be presented at ICSE. And they've done it by building a really high quality and well-organized team. So just in the main conference alone, 20 track chairs, 300 plus committee members, of course, orchestrating the work of many thousands of authors. And I think it's produced a really wonderful program. And I don't want it to go without saying that for all of the 30 workshops and co-located events, there's just as significant of an activity going on there in terms of the leads for those meetings, their tracks, and their committees and their authors. So just a great deal of thanks for the content team. But there's also an operations team, and I've mentioned the operations team before, and I'm talking now about the virtual operations team. At the in-person ICSE, there's another completely orthogonal operations team, and I will be thanking them there. But I've shown Oscar and Claudia and Fabio's pictures before. So Oscar's been wonderful to work with. And these people have been working incredibly over the last 8 weeks, pretty much every day, including weekends, many hours. Oscar's been in charge of researcher, but also connecting researcher with Midspace. Fabio was tasked with, getting the entire program up on Midspace and getting that debugged. And Claudia has been interacting with all of the workshops and co-located events and kind of really, really thoroughly and promptly supporting their information needs and just done an amazing job. Dana mentioned that we had session and backup session chairs and backup session chairs. And Fabio wins the award for most times invoked as a backup to the backup to the backup. I think he did 4 sessions in that way. So just jumping into the breach and helping smooth things out. And that's greatly appreciated.
If I can add, Matt, I don't think that Oscar and Fabio have slept in the last month. I worked with them like throughout, like 24/7. Oscar, I love working with you because you go to bed at 4 a.m., which is when I go to bed on the on the West Coast, although you're in Spain. So it worked beautifully that we had so much overlap. And I've met you before, but I haven't met Fabio. And I feel like we are so close now, having troubleshoot so many things together. So thank you from me as well for doing this fabulous job. Yeah,
and if you're not aware, Oscar and Claudia also contributed greatly to last year's ICSI. So this is doing this job 2 ICSIs in a row, just an amazing contribution to the community and much appreciated. Dana did mention the student volunteers team, and there have been a couple of comments about the sort of the professionalism and the calm in the face of adversity that the student volunteers have shown. And that's due, of course, to the kind of innate competence and kindness of the people who are in that role. But I think it's also due in some measure to the organization that's been provided by the student volunteer team. So the resources they've made available to them, the support network that's been provided for them, the students really felt like they were part of a team and they could just execute their role and the system would have their back. And that's really due to Laura, Michael, and Alvin's work. So much appreciated. And I was program co-chair back in 2008. And my job pretty much was done when we set up the program. And that was it. But this year, Dana went way above and beyond the call of duty, and she has been intimately involved in all of the operations. So the reason she knows everyone's been online all the time is because she's been online all the time. So thank you very much, Dana, for going way above and beyond the call of duty. What I really want to say is that it's been wonderful working with this great team on the first week of the ICSI Festival, and I thank you all very much. And at this point, I'll hand it over to Lori. So unshare.
All right, and you can hear me?
Yeah, I can hear you.
All right. Okay, so I am speaking next as the steering committee chair, and I can thank the thanker. And so, like Matt, he's really given a picture of how people have gone way above the call of duty, and COVID has made that happen. And so I'm the steering committee chair because I was in 2016 the program chair, and I'll tell you what, that was hard, but we didn't do it 3 different times. And so, like, when I think about what Andreas and Daniela and Matt have done, like, I cannot even imagine how much that's taken over their life. And so I really, really full heart want to thank you for your contributions to the community, the commitment that you've exercised, going well beyond the call of duty. So round of applause for all of the organizing team, as well as these 3 and everyone. So thank you so much. So when I think about Matt, I think in the steering committee meeting in 2020, so, we had been through, the North Korea not, what are we going to do? And then the steering committee meeting, Matt said, well, what do we do about COVID going forward? And I thought, come on, Matt, 2022, like, it's done by then. And I thought he was being a bit pessimistic, but he was being realistic. And so, dealing with this 2 years later, it's just a tough thing. And as a community, we need to think about what does it mean going forward, because the level of work that these three and all of the volunteers have gone through, is not necessarily sustainable. And that's something that we'll be talking about as a steering committee when we meet. We did usually at the closing, we announce the next one, which would be 2026. So usually I have the pleasure of announcing that, but we're having the steering committee meeting in a couple of weeks so that we have the ability to digest what has happened here in 2022. So once we choose that location, we'll send it out on Twitter and whatnot. Along those lines, keep in mind that, so that's 2026 that we're choosing. 2027 will be in Europe. So all of you Europeans thinking, do we want to host ICSE? Don't be scared by what we just said. By 2027, this will be smooth. So if you're thinking about, might you want to do it, in the fall, we'll have a call for the locations in 2027. And let's see. So some things I just want to say before we start to pass it off to the future ICSEs. Some things that are coming. So ICSE 2023 is going to be, more classical. The deadline is going to be similar to the past, but 2024, there's big changes underway. So we established what we now call the SE3 committee. And it's a meta committee of steering committee chairs and steering committee members from ASE, FSE, and ICSE. And lots of cooperation has gone on in that committee to, really for the benefit of the overall software engineering community. And so each conference has different things that it will affect them. In 2024, big things for ICSE. So we will institute dual deadlines in ICSE 2024, which means you'll have an opportunity early in the year, I think it's March, I should have checked that, to submit your paper and go through an earlier acceptance process, maybe having the ability for a revision before the accept reject. And then there'll be a later one as well. So dual deadlines coming up in ICSE 2024. We also moved ICSE earlier. It's now going to be in April. And so when we talk about 2024, then we're talking about Portugal, Anna and Rui's conference. And so that will be in April. And when in this SE3 committee, we spread the three conferences out throughout the year. So they're spread further time-wise, and also have it be that each year there's a conference in the US, in Europe, and in non-US in Europe. So, hopefully you'll have one of the major conferences near you. So keep your eyes open for those types of things. And that's really all I wanted to say. I look forward to seeing all of you in person. Yeah, so excited for that, and appreciate all of the precautions that Matt laid out. I was at a Kentucky Derby party last Saturday, and I think 75% of the people at that party got COVID. So got to watch out. We don't want ICSE to be a super spreader event. So, all of the precautions that Matt laid out will be great for the community, and we get to see each other in person. And so I look forward to that. And again, from the bottom of my heart, thank you all for making ICSE happen in 2022. And now I guess we pass it to John, which is a video, right?
I think I'll play the video.
Okay. All right. Thank you so much.
You're welcome.
Hi, I'm John Grundy. Welcome to the 45th International Conference on Software Engineering, to be held mostly, I hope, in Melbourne, May 2023. We're aiming for a substantially in-person meeting next year with some supporting hybrid options. Here we'll have a strong technical program, range of co-located events and workshops. We'll put a strong emphasis on community networking and development, and we hope to build some very valuable industry and society engagement as well. Pre-conference workshops, co-located events will be on the Sunday and Monday. We'll have the main conference Tuesday to Thursday, and the post-conference workshops, co-located events, the Friday and Saturday. May is autumn in Melbourne, sort of temperatures in the sort of coolish range. but most days should be sunny and low humidity. It's a pretty exciting time to visit Melbourne, all kinds of things going on. However, after our ASC 2020 and 2021 and our recent XE experiences, we're certainly planning to have some hybrid options available so you can attend as much as possible virtually if need be. Melbourne's Australia's second largest city, voted the most livable city 7 times in a row. It's a very nice place to visit, all manner of interesting shopping, eating, event activities. It's a major eventing and sporting hub. It's also a large IT industry. It's got more than half Australia's top technology companies headquartered here. We produce more software engineering and IT graduates than any other city in Australia. It's a games centre, but also has a large amount of education, retail, advertising, learning development here. And there's a large amount of collaborative research between industry, government, and our local universities. We're going to have the conference at the Melbourne Convention Exhibition Centre. A few little pics there. It's a very nice, world-class event centre just at the south side of the city on the Yarra. And it's a pretty short walk to the main central business district. The South Wharf Precinct has a very wide range of hotels, eating, shopping, and again, there's a option to go into the city, which is close by. A little example of the surrounds, lots of shopping, lots of eating, lots of hotels, and a very short walk into the central part of Melbourne. Then there's a lot of further afield things to do. Yarra Valley, where I live, lots and lots of wineries, Healesville, the wildlife sanctuary, Phillip Island penguins, and many other things. Lots of central city things, the cool, interesting laneways, etc. World famous Great Ocean Road, Gold Rush, etc. Then further afield, of course, there's other major Australian outdoor landmarks and many other interesting places to visit if you're coming down under, which I hope you will. Technical track will be 1st of September next year, and workshop proposal at the end of the month. In October, we've got the Software Engineering Society, New Ideas, Software Practice, Software Education, and Technical Briefings due. Demonstrations late November, a student research competition at the end of the year. January, we've got Journal First and Artifacts due. And then in February, Posters, Doctoral Symposium, and the Industry Forum. Trying to keep the website as up to date as we can, so there's quite a number of calls there already. We'll put out the co-located event ones, hopefully in the next month or 3. Keep watching that for upcoming information. So please consider coming to XE 2023 next year in May. All the best. Thank you very much.
These past months, he had his also times of hardship in the family, but he was always there, and he really empowered us to do our good job. And we were so proud of working with Matt. So thank you, Matt, on behalf of our team. It has been an extraordinary memory that I'll have with me for a long time.
Yeah, it was great working with everyone. Yeah, and Slack was over 20,000 messages. That's what our Slack.
I don't know how. I keep thinking about Jane when they did this first virtually. How have they done it? I don't know if you had used Slack. How you've done your massive coordination without it. But I can't wait for the celebration in person, Matt.
I think we're live, Laurie.
Are we? You're still muted, Laurie.
Anna, you can share your screen.
Laurie, lower left corner.
That's okay. She's saying go ahead. Anna, you can share your screen. Unmute, share your screen, and then we'll play the video after.
Okay. Just a moment. I think you are all seeing my screen, right? Is that right?
Yes, we see it.
Okay, so great. So as you already know, ICSI 2024 will be in Lisbon. Me and Rui are the general chairs, and we have the great pleasure to work with Margaret and Abik as program chairs. As Laurie already said, we are going to have ICSI a little bit earlier. It will be on April. And we will have our website ready and live next week or in the following weeks in the in-person week of this ICSI edition. Just to tell you, of course, that it will be a pleasure to welcome you all in Lisbon. And I would ask Matthew to now show our video where you all will have the opportunity to know more about our city and our country.
So Ed, I don't see their video in my change live stream source, but there's a second video associated with this session. Can you play it out?
You are talking to me?
You're live again, Matt.
Okay, great. So the video is available in the session that you're currently watching. You can check it out. I'm sorry we couldn't play it in the normal flow of things here in the backstage, but yeah, looking forward to visiting Lisbon again. Always wonderful to visit there. And oh, Laurie's back, so Laurie can say the words I was just going to say.
Yeah, sorry about that. Technical problems at the last wrong moment. Anyway, and so Tim and Lionel, so no one's here, I believe, for ICSI 2025. But just to say, ICSI 2025 will be in Ottawa. So we thank Tim and Lionel.
Tim's here.
Tim's here. Tim's here.
Oh, Tim's here. Okay, perfect. I didn't see you earlier. Okay, go ahead, Tim.
Yes, I'm here. I just suddenly realized that I've got an issue. Hopefully I can share my screen. Yep, there we go. Just a second. All right. So in ICSI 2025 is going to be in Ottawa, and following the directions from the steering committee, we will be starting in April. So the time period, April 26th to May 3rd, probably some events a little bit before and a little bit after that as well, depending on how things work out. So here's the four co-leads of the committee. You all heard from Lionel earlier on. So Lionel and I are the co-general chairs, and we're happy to introduce the co-program chairs, Karina Pazzarino and David Lowe. So we really look forward to working with them in the coming few years and get the program together. We have a large local committee already set up. These are some of the local people. We are going to be reaching out to a lot of other people to be volunteers to do other things in other geographical areas. And so if you go to this bit.ly link, 2S, WZI 6 capital Y, then you can volunteer or provide ideas for us. We're looking forward to that. AC 2025 is going to be in the Shore Center. You're seeing boats on the canal. Because we had to move it back to April, the canal won't be active. It doesn't get active until about 10th of May, but that's the way it goes. Nonetheless, the Shore Center is a great place. It's directly connected to a large hotel, the Westin. Indoors connection to the underground LRT. By then, you should be able to get from the airport to the right to the venue without having to go outside. And it's a short walk to Parliament, University of Ottawa, the market, lots of other nice places in Ottawa. So for those who don't know the geography, this is where we are, a relatively short geographic distance from major cities like Toronto, Montreal, Boston, New York, Detroit, Chicago. Easy to get to. Metro population 1.3 million. English and French is spoken widely in Ottawa. And we have the UNESCO World Heritage Rideau Canal, which will be right by. And we're gonna have various events at great museums. And there's lots of local restaurants that are really nice. Ottawa hosts an intensive software industry, so we're going to be getting a lot of these companies involved. It is the most technology intensive, that's per capita of its workforce working in software in Canada. 11.3% of the workforce in ICT, government being the other big employer. And so 980 companies in the general vicinity. So we'll see you all in Ottawa in this time period. I will be in Pittsburgh along with Lionel and many of the other organizing committee members. So if you want to chat, just come and see us. Or else, as I said, go to that link, the bit.ly link to capital S, WZI 6 capital Y, to provide any input you might have.
All right, thanks, Tim. And so I guess we'll close the closing ceremony now. And just wishing all of you a great, safe travels and healthy travels, and really looking forward to seeing you all in person. Thanks so much, and thanks again to the organizing committee.